Good morning. This is Kasturi Day. Today, again, I'm going to discuss the matter chapter according to ICSE syllabus class 8. Okay, and this in my last video of this chapter, I discussed about the interconversion of the states of matter. Okay, so I'll start today with the uses of the states of matter. That is water. We know that there are three states of matter, that is solid, liquid, and gas. And water uh, is an example of a liquid state. Okay, it can change into steam which is a gaseous state, and can freeze into ice which is a solid state. And these changes that take place in nature provide us with the ice or snow and fresh water. Okay, so in the nature we get water, snow, all these from these states of matter due to the states of this matter. Without these changes, life would not have been possible. Without water, without this changing from ice to water or water to steam, all these changes of the states of matter, all these due to these changes only life is possible on the earth. Okay, so water is changed to steam by heat energy, which is used to drive turbines in the thermoelectric stations. In the thermoelectric stations, when the turbines are run, they are drive, turbines are this energy is used to drive the turbines in the thermoelectric stations. This energy comes from the steam, that is water. When it gets converted into steam, that provides and that is provided with an energy. Okay, that provides us heat energy, and that is used to drive the turbines in the thermoelectric stations. Now, if metals are heated, they melt. We know that when the metals are heated to a certain degree or to a certain degree of temperature, they melt. Okay, and when these metals are poured into molds, okay, they solidify and they form predetermined designs. Okay, the molds, they are of predetermined shapes. Okay, and when the molten metals are poured into these molds, they solidify into predetermined designs. All the immovable parts of the machinery are cast out of these molten metals. Okay, then if air is liquefied, like oxygen, nitrogen, they can be separated from the liquid after the liquefaction of the air. Okay, oxygen is a gas and is then used for artificial respiration. Then nitrogen, which is also a gas, and it is used for making fertilizers. Okay, so in this case, in this, after the liquefaction of the air, the particular oxygen, the particular gas oxygen, or the particular gas nitrogen, they have separate uses, and that can be done after being separated from the air, because air is a mixture of all these gases. Okay, so after separating them, they can be used for particular purposes, like oxygen for artificial respiration and nitrogen for making fertilizers. The room fresheners are based on the property of sublimation. Okay, the room fresheners, they the certain solids are there inside the bottle, and which after getting converted into gas, they that is due to sublimation, they provide some room fresheners. Okay, next we come to law of conservation of mass. According to this law, mass can neither be created nor be destroyed in a chemical reaction. Okay, so however, it may change from one form to another during the reaction process. During the chemical reaction process, mass can be changed from one form to another, but cannot be created nor be destroyed. It can also be stated as, in a chemical reaction, the total mass of the reactants, that is equal to the total mass of the products. There is no change in the mass during the chemical reaction. For example, for this we need to prove an experiment. Okay, for this, what happens, we should take 20 ml of silver nitrate solution in a conical flask, clean conical flask, 20 ml of silver nitrate solution. Then an ignition tube is taken, and its neck is tied with a thread, and it is lowered down. I mean, in it conch HCl is poured, that is hydrochloric acid is poured in this tube, ignition tube, and this tube is carefully lowered down in the conical flask, that in such a way that no HCl, no conch HCl drops into the silver nitrate solution. Okay. Now a rubber cork is fixed in the mouth of the conical flask. Now, so that the ignition tube remains suspended above the silver nitrate solution. Then the mass of the conical flask is recorded with that HCl inside it. Okay, by a physical balance. Next, the conical flask is then tilted so that the contents of this that is the silver nitrate solution, that a conical flask which has the silver nitrate solution, and the tube, the ignition tube which is containing the HCl, conch HCl, that mixes. Okay, and there is a chemical reaction should take place inside that flask. Okay, then we see a white curd precipitate is formed because silver nitrate solution reacts chemically with conch HCl to form a curdy white silver chloride, and nitric acid is formed. Okay, now again the mass of the conical mass of the conical mask of conical flask is recorded. Okay, it is noticed there is no change in the mass. Okay, that is sum of the total sum of the reactants, and the mass of the total sum of the reactants and the mass of the products, both are same. We see after weighing both the first before the reaction and after the reaction, the mass remains the same. This proves the law of conservation of mass. In the above experiment, Lavoisier demonstrated the importance of careful measurement of mass, which led to the discovery of another law, that is law of constant proportion. Now, there's a note that the above experiment can be carried out by using the following solutions also. So, if in the experiment which I discuss now, that contains silver nitrate solution and conch HCl, but the following solutions, they can also be used for this, proving this law of conservation of mass. Okay. So, the following solutions are copper sulfate solution with sodium carbonate solution, barium chloride solution with sodium sulfate solution, and lead nitrate solution with sodium chloride solution will also give the same result, same will prove the law of conservation of mass. Okay. Next is to prove the law of conservation of mass, it is necessary to carry out the experiment in a closed container. So, some precautions are to be maintained to prove this law of conservation of mass. That is, it is necessary to carry out the experiment in a closed container. Otherwise, if the product is gaseous, it may escape. Okay, and the desired result may not be obtained. That is, the mass will not be same with the mass of the reactants and the products may not come as same. Okay, for example, when wood is burnt in air, then ash is formed. Okay, the mass of ash is less than that of the wood. So this is due to the fact why this happens, because the mass of air before the reaction, the mass of gaseous products formed after the reactions are not taken into consideration. Okay, so the air which was there when the wood was not burnt in the first case, when the wood was as a reactant. Okay, so that time mass of the air was not considered, and when the ash is formed, again some gaseous products also come out, so that mass is also not considered. That's why there is difference of mass between reactants and the products. Then when magnesium ribbon is burnt in air, a white solid magnesium oxide is formed. Now the mass of magnesium oxide is more than the mass of magnesium. This is also because the mass of oxygen is not considered in the first case, that is in the reactor when it was in as a reactant. Okay, and if that is not considered, that is considered the total, when if the oxygen mass is also considered, then the total mass of the reactants and the products is found to be almost equal. Okay, next is, okay, So this is the end of the chapter, and please go through this. If you have any doubt, please do write in the comment box, and also do press the like button, and share with your friends so that they can also be benefited from these videos. And do subscribe to get the notification of my next video, and the next video will be of the physics question answers, the electricity chapter. And in my next after that, I will start with the language of chemistry. With that, I will discuss the question answers of this chapter. Okay, so thank you for watching, and have a nice day. Thank you.